Hello and welcome to this video on the reverse chain rule. This is a bit like when we were looking at f of ax plus b, in the sense that we come up with a suggestion and then we differentiate it to see how we might need to adjust it. There are two specific examples. The first one, it says, is when we have an integral of the form k times f dash x over f of x, i.e. The differential of the function is on the top and the function itself is on the bottom. Which it suggests we try log of fx for. And then the other one is of the form the integral of k f dash x times f of x to the power of n, and it suggests that we try f of x to the power of n plus 1, and again differentiate to check and adjust any constant. I'm going to look at two examples of the second one and one of the first. So for our first example, we've been asked to integrate 4 over 8x minus 1 squared. So if I is the integral of that, I'm going to call the actual thing 4 over 8x minus 1 squared. I'm going to call that I dash. Okay, and it is of the form k f dash x f of x to the power of n. N is minus 2, and the f of x is 8x minus 1. The differential of that is 8, so we have got some multiple of the differential of 8x minus 1 there. So if I add 1 to the index, I get 8x minus 1 to the power of minus 1, and that is what I am going to start from. And I'm going to differentiate it, see what happens. So using the chain rule, I'm going to be multiplying it by 8 and minus 1, and the index will drop to minus 2. So y dash will be negative 8 over 8x minus 1 squared. So if I compare y dash with I dash, I can see that y dash is negative 2 lots of I dash, and hence y is going to be negative 2 lots of I. So that means that I is minus a half of y, and therefore that's minus a half lots of 8x minus 1 to the power minus 1, which I can rewrite as minus 1 over 2 lots of 8x minus 1 plus c. And as you've probably heard me say in another video along the same lines, I would only use this method after integration by substitution was intuitive to me. Okay, this time we need to integrate 4 over 8x minus 1. So that means that I dash is our 4 over 8x minus 1. And that is of the form f dash x over f of x times k, because the differential of 8x minus 1 is 8 again. So this time we're going to try a logarithm. So given that f of x is 8x minus 1, we're going to try log of 8x minus 1. So using the chain rule, if y is log of 8x minus 1, then y dash is 8 over 8x minus 1. So comparing y dash and I dash, again y dash is 2 lots of I dash, because 8 is twice as big as 4. So y equals 2i, and that means that I is half of y, so I is half log 8x minus 1, and I'm covering the c there. Okay, so finally let's imagine we've been asked to integrate cosec squared 5x cot to the power 8 5x with respect to x. So I dash is cosec squared 5x cot to the power 8 5x, and that is of the form k f dash x f of x to the power n, because the differential of cot is cosec squared. So we've been asked to try f of x to the power of n plus 1, so that means trying cot 5x to the power of 9. When we differentiate cot 5x to the power of 9, we get minus, because it begins with c, times 5, because there's a 5x in there, cosec squared 5x, because of the chain rule, times 9 cot 5x to the power of 8, which can be simplified to minus 45 cosec squared 5x cot to the power 8 5x. So this time when we compare y dash and I dash, we can see that y dash is minus 45 times I dash, hence y is minus 45i, I is minus 1/45th of y, and hence the answer is minus 1/45th of cot 5x to the power of 9 plus c.